Okay, good morning, everyone. Please get seated. I hope you enjoy your break just now. Okay, please close the door as well. Yep. Okay, my name is Wei Yang, and my topic is transforming operations with observability. So instead of making this like a talk, I prefer more like a sharing sessions where later we can exchange knowledge or thoughts or even the difficulties you are encountering at the moment. So for your information, I'm a heavy user of observability tools. It saved my life, saved my project multiple times. Just to give you a sense, most of the time, I have my own dashboard with customized graph and using combinations of metrics and mathematical formula just to alert me before any disaster happen. All right. So first of all, let's talk about what is observability. Do you have any understanding of this observability? So observability is like basically the collections of insight to understand the inner state of the system. So in other words, the visibility of what is happening inside your system, usually in the form of graph or numbers. So as you all know, the software world is rapidly evolving. Now we have microservices, containerizations, even your GCC 2.0 and many more. Same thing for monitoring. We now have observability, which various methods or various tools and the community built around it. The main reason is that experts start to realize how important is this observability to a system. All right. So what is the difference between the conventional monitoring and today's observability? I believe all of you have certain monitoring or observability in place for your system. So what is the difference? A simple analogy is that monitoring is like using a binocular, which allows the sailor to spot the ice on the surface of the sea. But observability is like using a sonar to detect how big or how deep is the ice. So in other words, the conventional monitoring only allows the view to the tips of the iceberg. But observability, on the other hand, is used to detect the hidden part and give you a better understanding of what you are encountering at the moment. So in short, monitoring gives you the what part, what is happening, what is the symptoms, for example, like your high CPU usage, your low disk space, your low memory, etc. But on the other hand, observability gives you the why or the how part. Why did it happen? How can we resolve it? All right. So these two, monitoring and observability, complement each other and work together to provide a complete picture of the system. So it's like similar to visiting a clinic. Doctor first will monitor your health by checking your heartbeat, listening to your lungs or your breathing. But for in-depth diagnosis, doctor will need to perform an X-ray. So, with just the surface monitoring, without observability tool, without using the right tool, when issue happen, you are like looking for a needle in a haystack. Let's say with basic monitoring in place, you saw that there is a CPU is having an upward trend. What can you do next? The system nowadays are so complex, and probably there are like 10,000 reasons that cause the CPU to surge, especially when you have SLA to meet. Do you think you have enough time to go through like the 10,000 lines of logs or 10,000 lines of code? That's why the observability tool come in place to enhance your monitoring. With that, you are able to recognize, recover, respond, and review after the incident. So many will actually underestimate the significance of observability. So it's actually just like launching a rocket to a sky. People tend to focus on the initial design, put a lot of effort in building, testing, until the stage of deployment or firing. But do not forget that rocket in operation, flying towards the destination, this stage is equally important. This is because a small mistake, a small deviation of angle, your rocket maybe explode, or not even reaching its destination. All your previous hard work will be wasted. So, and hence, here comes the observability part, where you can see NASA ground level, the ground station, they have thousands of monitors just to make sure the rocket is healthy and on track. All right. So for observability, there are 3 pillars which provide the insights into the internal status of the system. I call this 3 pillar DID, DID. So first D. Oh, sorry, too fast for that. Review another card. Okay, so first D for detect. We use different metric to detect anything wrong with our system. Usually it comes together with an alert, be it SMS or your email alerts or whatever. As long as the threshold is exceeded, we will be alerted. Advanced user can actually make use of combinations of metrics and mathematical formula so that preemptive action can be made before your system crash. Okay. Secondly, I for identify. We use trace to identify where has gone wrong. This is especially important when you have a complex system. Hundreds of microservices, thousands of endpoints and API call. So this tracing part help you to narrow down where is the bottleneck and where is your breaking point. Then finally, D for diagnose. So observability use centralized on and contextual logs to provide events with time to tell us what has gone wrong. Not to confuse, you do not need to go through the 10,000 lines of log here. We are actually looking at contextual logs or logs in context, which means relevant log data are correlated with your specific trace or event so that you have a holistic view of what triggered the alert or the error. Later, I will show you more in the demo. All right. So with these 3 observability, the DID, you can benefit in the following. Proactive issue detection. You can be alerted even before the system breakdown. This will reduce your MTTD significantly, mean time to detection. Secondly, faster incident resolution. With observability tool, you can easily trace and narrow down to the root cause, which in return greatly reduce your MTTR, your mean time to recovery. Finally, you have a better performance and reliability. With this come with improved operation efficiency and of course, your user satisfaction. All right? I can tell you, don't overlook the significance of observability. DBS is actually a good example. When their system went down just for a brief moment, do you think the people still remember what good features or what functions that the system provide? I can tell you, people only remember that the system is not reliable. One outage is enough to affect your user confidence level permanently. All right? or one side benefit as well, for those who need to prepare reports, with observability tools, you can easily get the figure like this MTTR or MTTD, for example. All right? Okay, so now you understand the 3 pillars and the benefit of observability. With observability in place, what you should actually look out for during your DID, your detect, your identify, and your diagnose. So actually, there are 4 main signals, which is outlined by the Google Site Reliability Engineering team. For most of the cases, you will want to have these 4 golden signals to be on your overview dashboard. So first, latency, time taken to serve a request. So usually we take the 95 percentile and sometimes with the average line to have a comparison. Then traffic, any surge of traffic which may cause the system to break, usually in the form of a transaction per second, basically your TPS or your RPS. Then followed by saturation. So basically, it's the resource utilization for CPU, your memory, your disk space, to indicate how close is the system to reaching its limit. Last and the most important one, your error rate. Okay, so with these 4 golden signals, you will have a good indicator of the overall system healthiness. All right? So this is our Kaizen approach in monitoring and observability. So for example, we have a typical cloud-native solutions with microservices interacting with each other. You can see ABCD over here. On the front end, we also have the end user with their web browser accessing our web application. So the application will be residing in one of the cloud provider like Amazon, your Microsoft, your Google Cloud, and using some of the cloud services like RDS or Redis. So the cloud service provider do come with certain monitoring on their infra or VM level, and as well as the service that they provide. So there are CloudWatch, your Azure Monitor, and your Google Cloud Monitoring. And most of the time, there will be synthetic monitoring, like your Canary and your Voga in place to inject simulated traffic into your application. So this will also provide another dimensions of monitoring. And finally, come to our Kaizen, which cover the middleware portion, like the JVM, your Tomcat, your Kafka. Additionally, it provides service level or node level monitoring. And also, it extends to cover the front end portion as well, the client side portion as well. All right? So with the 3 pillars I mentioned previously, the DID, detect from insightful metric, identify by distributed tracing, and diagnose with contextual logs, we have the entire system covered with monitoring and observability. And the best part is Kaizen observability tool comes in a package as a whole with no additional coding required or integration required. It comes along with the application design stack, which means the observability tool is even available at your initial build and design phase, which you can make use for your testing as well. All right? So in fact, when it comes to observability, you want it to be as comprehensive as possible. It's always good to have a different prop at different part of the system so that you have a full visibility and full control of your system. All right? So let me share a case study where monitoring and our Kaizen observability comes into action. All right? We have an application to register entry to certain concert, like the Taylor Swift one, which we are expecting like hundreds of thousands of participants. Then on the ground, we are actually experiencing slow registration and the queue is starting to build up. So if you still remember, the 3 pillars of observability that I mentioned, DID, let's revisit them and see how we can make use of this to resolve our, just now, the slow registration issue. So first, we detect by looking at the 4 golden signal. Just to let you recap, the 4 golden signal are latency, saturation, your traffic, and the error. So in this case study, latency in the form of response time and your saturation in the form of CPU utilization are compromised. So even before we receive calls or complaints from the ground, the day 2 operation team in the command center, they have already received alert. So 2 email alerts actually fire to them with the CPU utilization more than 60% and the response time more than 10 seconds. Then we quickly identify the bottleneck by distributed tracing. We look for slow trace, and then we narrow down to a particular API call with issue. All right? So there are a list of API calls with their respective request time in the graph. So, and with this, we can easily notice where is the API call with issue. So in this case study, it was the registration search user, which is taking the 10 seconds. So finally, once we narrow down to a specific API call, together with a trace, now we can diagnose further by locating the span and finding out the root cause. So this is how it looked like after we narrow down to a specific trace of the slow API call. We then further pinpoint to a specific span. From the span, we will be able to tell which operation actually caused the slowness. So if you want to investigate more, you can actually check the contextual logs for this particular span. There are a few terminology here, what is span, what is trace, which I can share a bit more later during my demo. All right? So in this case study, we found out that there was a SQL statement which is getting slower and slower. And finally, based on the SQL statement, we checked the DB and we realized that one of the table was not indexed. That's why the query getting slower and slower as the registration accumulated. So after performing the indexing, we monitor the dashboard for a while and the operation is back to normal again. So with the case study, I hope you all have a better insight on how the observability and how Kaizen tool play hand in hand to help your system to be more reliable and more robust. All right? So before I go into my demo, I hope you guys by now have a better understanding on how observability, the new oil of operation, works. All right? So the 3 key takeaways are monitoring and observability work hand in hand to provide a full picture of system health. Also, we want the coverage to be as comprehensive as possible. Just like your insurance, you have your life, you have your accidents, you have your hospitalization to ensure a full coverage. And then finally, the 3 pillars that I mentioned, the ID, and also the 4 golden signals. All right. So let's move to my demo now. Deep dive into observability. All right. Okay, so this is an example of an overview page of our Kaizen observability dashboard. All right, so we have included the 4 golden signals into the dashboard. Let me recap again. Your latency, your traffic, or your saturations, and your error. So on the left-hand side, we have the application response time per service. It's actually at 95 percentile, and you can see it's actually a different color representing different services. Then you also have the response time further down, your response time per API call. So with these two graphs, you can cover the latency part out of the 4 golden signals. So on the top right, let's move to the top right, we also have the error rate per service to cover the error part. And also the bottom right, which is the traffic, which is split by services also, to cover the traffic part. So then for the last golden signal, saturation, actually we have another dashboard dedicated to it. Let's go to the saturation dashboard. You can see that there are CPU utilization, your heap memory, your garbage collection percentage, and many more. So this graph is actually targeting at container level, which complement your VM level saturation, which you can find in your CloudWatch, for example. So different dimensions or different depth. So it also depends on your requirement, your number of graph, and also the number of personnel assigned for your monitoring. So the 4 golden signal can actually be at one glance view dashboard, or it can be split into multiple dashboard like this. All right. So let's go back to the main dashboard. All right. Then further down of the dashboard, we also have a service map. This helps you to visualize the interactions between multiple services in your infrastructure. So this is very useful when you have a complex system with complicated service dependency. So this graph not only shows you the direction of your request and also your traffic, the number of requests per second, and also the response time also, your how many seconds per request. All right. So now I will show you how the 3 pillars of observability work, the DID, the detect, identify, and diagnose. So imagine that your system is currently online. Then suddenly on the error graph on the top right, you see that there is an error rate of 45% for this trademark service. Other than looking at the graph, at the same time, you also receive the email alert, for example, that your so-called error rate has been breached. So this is the first D for detect. Once the error is detected, we now can actually proceed to identify actually what is causing the error, which is the I part out of the DID. So what you need to do is, as simple as that, just click on the error service, and then select trace. And then this will direct you to a particular trace. So trace is basically like representing the entire journey for a single request from the start to the end, providing you a comprehensive view of how the request is being handled across multiple services. So from here, we click one of the trace because the error is still happening at the same time. We select one of the traces. And then from here, we have identify and narrow down to a particular trace. So this is basically the I for identify. All right. Next, you will need to scan through the span. So span basically is like representing a specific operation or task that occurs within a trace. So you have a multiple span within a trace. So here we can notice that there is actually a error thrown, the red exclamation mark here. What we need to do, we expand to the deepest span with error, which is likely the root cause. Okay, so you can see that this is the event that actually trigger the error. And thus, we managed to diagnose the issue. Which is the last D, diagnose for our pillar. So it's actually as simple as this. All right. So another useful tool I would like to share is we also have front-end observability, or what we call RAM, so-called real user monitoring, which monitors the performance on the client side or the browser side. So let's move to the front-end dashboard. Yes, this is a front-end dashboard. So you can see that there are a lot of metric capture, like your page load, your first input delay, FID, etc. In most of the cases, when end user is complaining on certain issue of on the page, like for example, missing menu or missing button. But when you check on your back-end dashboard, there's no slow trace, there's no error, and so then it's likely due to the front-end issue. So with this front-end observability dashboard, if there is any error or exceptional thrown, it will be reflected as well. So you can see there is a 5 exceptional thrown or error thrown. So we just click into it. All right, you can see that actually there is an unexpected token found in one of your JS file. All right, so let's move back to the front-end dashboard. All right, so if you scroll a bit further down, you can see that there is also a pie chart showing the traffic to all your pages. So with this, you actually can optimize the most frequent visit pages to make it load faster or more user-friendly, and so on. All right. So all these Kaizen dashboard that I've shown you provide the observability to your system, even during the initial stage. So not only your day 2 operation team, but also your developers, your development team can make use of them during the initial design and build stage. And not to forget, these observability tools actually is ready to use out of the box with no additional coding or integration required for all the applications that build in Kaizen. All right. And also, it depends on the agency policy as well. So during your maintenance phase, the app team can actually be granted access to the so-called observability tool as well, so that the lead time between your ATFM and your maintenance app team can be greatly reduced. So all right, that's all for my sharing session. Let's proceed to the Q&A. Let's see, got any interesting question for me? Let me do a refresh. I saw one very interesting one. Okay. So what is the overhead for Kaizen observability? And will it compete resource with my main application? Okay, so this is actually a very good question. Many will actually worry that whether my performance of my main application will be affected by this dashboard or the metrics that collected from the observability tool. So actually what we do, all the applications that we build in Kaizen, we turn on all the so-called observability tools. We found that actually there are very, very minimal impact to the performance. But having said so, it's always good to practice for your observability stack to have a VM level isolations. Or even you can set a CPU limit or your heap memory limit to your observability services, so that it will not compete any resource with your main application. All right, I hope that answers your question. All right. I think I'm running out of time, so please feel free to look out for me during the lunch session later. All right, thank you everyone.